My name is Zhang from Department of Philosophy, but I'm also affiliated with the General Education and Core Curriculum Office. So it's my great pleasure to introduce the speaker today for our second seminar on science in this term. So our speaker, Professor Zhang, is from Carnegie Mellon University in the United States. We're actually very grateful that he can speak to us today during his jet lag. He just flew from Pittsburgh to Hong Kong yesterday, which may explain why we feel so cold today. So Pittsburgh is a very cold city. And depending on your attitude towards artificial intelligence, the talk may make you warmer or even colder. But let me just say a few words about Dr. Zhang. And so he, although he's quite young, he's already a seasoned player in the field of machine learning. And he serves as a senior program committee member, for example, of many top conferences in machine learning. So he really knows this field throughout. And he already made some very important groundbreaking contributions to causal learning, as he will talk about later in this talk, in particular, and also to machine learning in general. So I think we can look forward to a very exciting talk today on machine learning and intelligence. Thanks.
Thanks, Professor Zhang, for the invitation and introduction. I can use this one. So it's really nice to be here. In such an international city, you can find such a beautiful and quiet campus. It's so nice. So today I'm going to talk about machine learning, and you can see how we can really go from efficiency to intelligence by making use of some machine learning techniques. And I hope that after this talk, you will see what machine learning is and how to interpret the machine learning results. And you can find a suitable method to analyze your data. You can find a suitable method to analyze your data and achieve your goal. So because you can have a big picture about the machine learning. Okay, and during the talk, if you have any questions, please just let me know, okay? I want to make sure you really see the problem, see the picture of machine learning. So here, we talk about machine learning all the time nowadays, right? We use Google search almost every day, I guess, right? And here you can see, basically, Google search analyzing your data, the data from users, and improve the results. We use, here this is basically 2 years ago, Microsoft AI is human in speech recognition. So now basically they can really do a better job than humans. And here this is AlphaGo, the series of AlphaGo players. Now they are much stronger than any human. And this is Amazon recommended system. So basically, they collect the data from you, and they can recommend what you want. And this is news from last year. Basically, the CMU AI team built a system which beats all human poker players, professional poker players. And it's the big news because the problem is very hard. And here we have robots. We have personalized service robot. Basically, the robot can collect your data and do a better service. And we have clinical diagnosis. Also, we have personalized treatment. And all those things will make use of machine learning, right? Uber, if you use Uber, basically Uber will combine your data, your input, and real-time traffic to optimize the route. So we make use of machine learning all the time. What's machine learning? Before I talk about what machine learning is, let's have a look at what artificial intelligence is. Artificial AI is kind of much broader. Why? Because AI, you can see the definition of AI is the capacity of a machine to imitate human intelligent behaviors of humans. So basically, this works well, right? Okay. Basically, you can do anything. You can just design some system to mimic what we do, our behaviors, and this is the artificial intelligence system. But if you talk about machine learning, you can see machine learning makes use of data. According to Arthur Samuel in 1960s, almost 60s. He said that the field of study, machine learning, is a field of study that gives the computers the ability to learn without being explicitly programming, So basically, you don't need to really tell the machine what to do. The machine will figure out what to do by making use of some data and analysis. And according to Tom Mitchell, who is the former head of the machine learning department at CMU, the goal of machine learning is identifying the underlying mechanisms and algorithms that allow improve the knowledge with more and more data. It just says if you have more data, basically the performance will be better, no matter what you do. You can do prediction, you can do modeling, you just make use of data. So you can see the difference between AI and machine learning. For machine learning, we don't want to tell the machine what to do exactly, right? We just define the problem, the task, and we give data. And then the machine will figure out exactly what to do. But for AI, it's more general. For instance, you can find some problems which are machine learning, which are not machine learning problems, but artificial intelligence problems. For instance, you can just design a system, robot, to do exactly what you ask the robot to do, right? You can just use, write 100 lines of code, right? Just tell the machine what to do and what not to do. Then the machine will follow the rules. This is the artificial intelligence system, but this is not a machine learning system. Why? Because you don't make use of data. Okay? With more data, you cannot improve the performance. So this is not machine learning, but this is artificial intelligence. Nowadays, more and more systems make use of machine learning, not traditional artificial intelligence. Why? Because we have so much data, right? And we can make use of data. We can really extract information from data. That's why machine learning is becoming more and more popular. So why do we use machine learning? Right? We have data, we want to see something, we want to do something, we want to achieve some goal. And in many situations, it's not practical for humans to do so. And in some cases, it's not possible. And we have to, on the other hand, computers can really do a very good job. They can solve problems automatically and efficiently almost everywhere. So we can talk about image classification. You have a lot of images. You want to see exactly what this image is, right? Maybe there's a bird, there's a tree, or there's some other thing in the image. And machine can do this very quickly and very accurately. And for humans, we don't have time to look through all images. And cyber fraud detection is a very important problem, especially in Hong Kong and China. Right? And financial fraud detection, healthcare, finance, personalized finance, logistics, entertainment, AI gaming, right? And self-driving cars. So in all those systems, we make use of data, and then we can machines can do a much better job than humans. So the problem is, before we really talk about what machine learning is, I want to give you a big picture about machine learning. So do you think the machine learning systems nowadays are very good? Yes, they are very powerful, but they are not ideal, they are not perfect. You can easily identify a lot of problems with machine learning. Here I just show some problems. We humans can really transfer knowledge very easily. For instance, if you play badminton very well, then it's so easy for you to learn to play ping pong and play very well, right? Because automatically you know how to transfer those skills. For machines currently, it's so difficult to really transfer knowledge, abilities, or capacities to solve new problems. And over here you can see this is a self-driving car. Nowadays, most self-driving cars use rule-based systems. So basically, there are so many rules. We humans don't really explicitly make use of such rules. That's why we can really handle completely new scenarios, right? If you are faced with some very new scenarios, you know what to do. But if you just use a rule-based system, in some situations you can make huge mistakes, right? This is the limitation of the current system. And over here you can see something funny. This is a system app, actually, software app developed by Google Photos 2 years ago. And last year they found something very, very funny. Basically, two African Americans were identified as gorillas by the system. And Google apologized for that. What caused the problem? Why is that the case? And you can see a limitation of machine learning systems. Basically, they mainly use the white people for training, to train their system. And finally, when black people use the system, you can get very wrong results. Okay? For humans, this is not a problem. We can easily solve this problem. Then you can see how difficult it is for machines to solve this problem. Later, Google said that they fixed the problem. Guess how they fixed the problem? Any idea? They just simply remove the label gorilla from the label list. So now, nothing will be labeled as gorilla. In any case, gorillas cannot complain, right? So basically, they solve the problem in this way. Why did they solve the problem in this very naive and funny way? It's because it's really difficult to equip the machine with the ability, the intelligence we have. Okay? Okay. So, and also I want to share with you some quotes I like very much. The first one is given by Newman. And you can see we should be optimistic about the future of machine learning and AI. I want to share this because a lot of people are really worried about the future of machine learning and AI. They're okay, maybe machine will take over in the future. So the first one, in reply to the canonical question from the audience, but of course, a mere machine cannot really think, can it? Newman said, you insist that there is something a machine cannot do. If you will tell me precisely what it is that the machine cannot do, then I can always make a machine which will do exactly the same. What do I mean? Basically, when we say, oh, the machine can't do this or cannot think, we don't really understand what it means. We don't really understand what think means. If you really know, precisely understand what think means, you can always provide the machine with this capacity because you know how to do so, right? And the second one is given by John Kennedy. So if men have the talent to invent new machines that put men out of work, they always have the talent to put those men back to work. So don't worry about the future, basically. We just want to make use of machines to facilitate our life, to make the world better. Okay, so in this talk, I will talk about some fundamental problems of machine learning. Basically, there are three categories of machine learning tasks and problems. They are supervised learning, where you have a teacher. Unsupervised learning, we don't have a teacher. And reinforcement learning, in which you don't have a teacher, you don't talk about a teacher, but you can receive reward from something. And then I will have a very quick look. We will have a very quick look at deep learning. Why? Because deep learning is so popular. Everyone talks about deep learning, and some people even think that deep learning is the only tool to do machine learning. And finally, I will say something about the causal learning. You can see how we can basically do something causal, more intelligent, by making use of machine learning techniques. Okay. So, if you want to see the detail, the difference between different machine learning algorithms and tasks, basically you should pay attention to the three things. One is data, what kind of data you have. The second thing is the task, regarding what is the type of knowledge that you want to discover from data. So you have the data available, right? In different scenarios, you have different kind of data, and you have different purposes. You have different kind of information to discover from data. And finally, because of those things, you can design algorithm to achieve your goal. Here, tasks could be very different. Sometimes you want to make prediction. You want to make prediction into the future. Say, I want to see whether this customer is interested in something, right? Or I want to see whether this person is trustable. It's a prediction. And in some cases, you don't want to do prediction. You just want to find a better description of what you see. Okay, you want to see the relationship between different people, right? It's not really a prediction problem. Don't have precise definition of the target you want to predict, but you want to see some relationships. This is a better representation or better description of the world. Okay, so here you can see the picture. Just try to have those pictures in mind. Then you can see the difference among those three categories. Supervised learning. Basically, whenever you do something, you should receive feedback from the teacher. The teacher will tell you how good your performance is. This is supervised learning. And unsupervised learning, you just explore the world. You just want to explore. You want to see what's inside. You want to see how to describe what you see. This is unsupervised learning. You don't have a teacher. This is reinforced learning. Again, you don't have a teacher that you see the detail, but you can receive a reward. This is you want to find the best solution to receive the best reward. Okay. So all of those things have a lot of applications in real world applications. So machine learning, right, we have supervised learning. You have basically there are two main tasks in supervised learning. One is classification, the other is regression. With the classification, you can do image classification. You want to see, oh, what is in the image. And you can do customer retention. You can do fraud detection. Basically, you can see you want to make prediction. You want to see whether some class label can be used to explain what you see. And this is regression. Here, what you want to predict is continuous. For instance, maybe you want to predict the future, say tomorrow the stock price. Now you can see this is just a prediction problem. Actually, usually use regression to solve the problem. You want to make prediction into the future, and the predicted value is continuous. Or you want to do so many weather forecasting, right? It's again you can use supervised learning. Why? Because you have a lot of historical data to make use of. And unsupervised learning. So here we have a lot of things. We have clustering. Here you can see we have recommended systems. You want to cluster all those products, items into different clusters, and then you can make appropriate recommendations. And we also have customer segmentations. You can group the customers into different categories, and then you can divide and conquer. You can find the best policy or best way to deal with them. And you also have dimension reduction. This is a way to make things better, to make things simpler. For instance, you want to do structure discovery. You want to see, oh, what's the structure underlying the data you see? Okay, now you can see the precise definition of those problems. Classification. What kind of data do we have? Here, we have a list of data records. For each of them, here we have a number of persons. For each person, we know the age, we know the average transaction value, and we know the value of the target, which we want to predict in the future. Here, we want to see whether the customer is a one and done customer. So this is the label. Basically, you have a lot of data called training data, which contains all the values for all those three things, the attributes and the target. And then you want to make a prediction. Now a new customer just arrives, and you want to make a prediction. You want to see whether this customer will be a one and done customer or not. This is a prediction problem, and this is a classification problem. Why? Because the target is, the value of the target is discrete. Sometimes it's binary. Yes, no, right? How can you solve the problem? So essentially, you can see you can make use of the attributes. You can find something to distinguish between different classes, and then you can make prediction. And similarly, you can do regression. Here the problem is similar but slightly different. You want to predict, say, Y, the number of electronic products the person has from the income. Again, you want to make prediction. You have income, and you can also make use of more attributes. You can use income, age, and so on. But basically, you have those data points and training data. Again, training data, and in the training data, you have the value of Y. You know, for those people, you know how many electronic products they have. And the goal is to make use of the data, training data, to make a prediction. So suppose now you have a new value of X. You have a new person. The new X value is here. You want to make a prediction. You want to see, oh, how many electronic products he or she is likely to have. So you have data pairs in those problems. Here, X is attributes. You want to make use of X attributes to predict Y. Y is the target, right? In the first case, you want to predict whether the customer is a one-done customer. This is Y. Then what's learning? Basically, you just want to solve this problem. You want to fit a curve, which is a function of the attributes, to agree with the data you have. Agree with, this term is pretty vague, right? And you can see the key is that you want to find a good function, good learning machine to generalize well, meaning that the learning relationship can be used to predict into the future, can make good predictions. And you can see in this problem, you may have this line. You may have this line, or this line, this curve, or this curve, or this curve. You can see they are very different. All of them kind of fit, kind of agree with data. If you use this one, there's some noise. You cannot perfectly fit those data points. However, this is very simple. And if you use this guy, it's very complex, right? it changed a lot, but you can perfectly fit all those data points. So which line would you like to use? Which curve would you like to use for prediction? In machine learning, a lot of learning theories were developed to solve this problem. Basically, we want to achieve this goal. We want the function to generalize well. That's why the function should be simple in some sense. And people came up with different ways to measure how complex or how simple the functions are. And finally, this problem has been solved very nicely. So in this case, it's not surprising that you want to use this line, because it's very, very simple, right? You can avoid the overfitting problem. Why? Because data is always noisy. You should not model noise. If you model noise, you cannot make good predictions for future persons. Here, if you know, oh, this should be the best function fx I can use, and then you can make a prediction. For a new value, I know, oh, this is the best value for y. Okay? You can make prediction without any problem. So this is regression. And there are many popular supervised learning algorithms. Here, let me just give some examples. Nearest neighbor. Here, you want to do handwritten digit recognition. You have so many digits, and you have a new one. Here, you have those things as training data. You know the label of 1, this is 1, this is 1, 1, 1, 2, 2, 2, 3, 3, 3, and so on. You know the underlying label. And you know you have the image. You can take the image, you have the image. You want to see the underlying label from the image. Now you have a new image. You want to identify which label it corresponds to. This is 1, 2, 3, or 4, and so on. So this method is very simple and very powerful. What does it mean? By nearest neighbor, we mean the following thing. Given this one, I want to find the underlying label. I just find that among all those 20 images, the one which is closest to this given test image. By closest, I mean basically they are very similar. They are the most similar. You can see this. The images are very similar, and they are just consider that class level as the best one for this new data point, new test image. This is called nearest neighbor. Okay, very simple, very useful. And sometimes, let me give another example. Here you can see a lot of records, a lot of data. With first record, you have age, income, whether it's the student or not, credit rating, whether this person will buy a computer. You want to predict the last column, Y, from all the other attributes of the persons. Okay, then you can do something like this. You can build a tree called a decision tree to solve the problem. So you check different attributes. Further, you check the age. If it's youth, then you check whether he or she is a student. If it's yes, then okay, he or she will buy a computer, and so on. So this is called a decision tree. You can make decision. You can make prediction by constructing the tree. And the tree, basically each node is just an attribute of the data. Okay? Now if you have a new person, you can easily make a prediction. And I just talked about linear regression, and you can also make non-linear regression. Basically, you just want to find a curve to fit all data points. And later, we'll talk about the deep networks, deep learning. You can see we have different ways, a lot of ways to solve the super learning problem. Okay. There are so many applications. This is stock market prediction. Given the previous historical prices, you want to make prediction into the future. If you can make very good prediction, clearly you can make benefit. So here, this is the fun. Basically, you can really see what the person is thinking about by analyzing the brain imaging. So here, they try to identify the thought from the MRI data. So you have the scan, and then they want to identify what you are thinking about from the scans. And at CMU, there's a team called mind reading. Basically, they want to read your mind by analyzing your fMRI data, AEG data. This is supervised, okay? And okay, so that's for super learning. Do you have any questions? Yeah.
Just clarify. So earlier you used the language of with the teacher, right? So basically, training data are teachers, right?
Yeah, exactly. So the teacher is a label. So basically, you want to predict something, predict Y, and then on the training data, you have the value for Y. That's why it's a teacher. The teacher will tell you, oh, it's too far, and the area is too big, right? You should get close to me. This is the teacher. But now we don't have a teacher anymore. You can see the difference.
Yeah, so in your previous slide, so I just wonder what how do you get those target labels in the training data? Is by report?
Yeah, they collect data, basically collect all the data from different people, and they
report their thoughts, and then they scan. Okay.
And sometimes they ask you to read something, right? To read something, to imagine what you are doing, and then they can collect the data. Yeah, very good question. Okay, so this is very common. Looks very interesting, but some people have some worries, right? How can you read the other people's mind? Okay.
My worry is that if you do, how dangerous that is. Anyway.
Yeah. Okay, so any other questions? Now we are going to see a very different learning task. Here, we just want to do the following thing. We have attributes, the values of attributes. We have different persons again. So here, this axis is income, and this is data of the person. Basically, you can see a lot of data points. Now we don't have Y. We don't exactly know what to predict. We have no idea. However, we want to analyze the data so that we can have a better understanding of the data points. You can say, oh, now I see. Basically, there are only 3 groups of people. Okay? Although I have a lot of data points, I know there are only 3 groups of people. Okay? This is much, much simpler. Right? You are basically the higher level of the description of the data. So in this case, you can see although we have data in a 3-dimensional space, X, Y, Z, 3-dimensional space, it's not in a full space, it's on some manifold, and then you can extract this manifold. When you find this low-dimensional representation, things will be much easier, much simpler. You can say, oh, now I just have a plane. Previously, I have data points in a 3-dimensional space. Now you can see, oh, I can see the relationship between different points, or between different persons, if the attributes are some properties of persons, very clearly. And in this case, this is called image segmentation. We have image. We want to divide the image into a lot of different regions, segments, to have a meaningful and high-level representation of the image. Here I say, oh, this is water, this is grass, and so on. So it's much simpler. This is a way to understand what you have, what you see. So how can you solve the problem? Basically, there are many algorithms. The first very popular method is called the k-means clustering. And you can see from the name, you want to use k-means to represent all the data points you have. Here you can see an example. You have so many data points, X and Y axis, right? Each of them correspond to an attribute of the data, the income, date, and then you want to find k groups to represent all data points. Here I turned out that, oh, there are 5 groups, and for each group I can just use a mean to represent the property of the group. Now you can see, instead of using all data points, I can just use those 5 data points, means, to represent the property of the data. This is very useful. Now I have a better understanding of all data points. This is called k-means. And in this case, you can see, again, we have a lot of data points in a 2-dimensional space. However, if I use this line, if I suppose all data points are on this line, I don't really lose a lot of information, much information, because they are very close to this line. This is called principal component analysis, because I just want to find the principal axis, a principal component of the data to represent the data. Now, by making use of this line, I have a simpler representation of the data. Now instead of 1-dimensional, it's a line, instead of the 2-dimensional representation. And sometimes this is very good. Why? Because the data is noisy, and probably those things are just noise. I can even have a better understanding of the data I have. This is called PCA, Principal Component Analysis. You can really see what they want to solve, what problems they want to solve from the names. And this is called autoencoders. In the last 10 years, this became very, very popular. So essentially, what that means, you have input things, like image, and you want to reproduce the same thing over there. They are very similar. However, here in between, you have a very low-dimensional representation, very simple representation, trying to capture the essential information in the image. Okay, here you can see the image, very complex. Maybe I just want to use, say, 5 variables to represent the information in the image. Then you can see I have to reconstruct everything about the image by making use of the decoder. This is a way to extract the essential information in the input. Okay, this is called autoencoders. So you can see application. Here you can do image segmentation by making use of k-means clustering. Very simple. We have a lot of colors here in the original image. Now if you use, say, 3 different colors, you can still represent the same image relatively well. However, it's very simple. There are only 3 different colors. So this is called segmentation. Very good. Very simple. Here you can do image clustering. You have a lot of images. You want to cluster. You want to divide the images into different groups. Then images in the same group are kind of similar to each other, and images in different groups are very different. You can see here. Here you can see sunset, flowers, and so on. You can do this. Clearly, this is unsupervised because there is no teacher. There's no target, right, which can tell you what to do. You just want to analyze the properties of the images you have. Okay? But it's meaningful because you can really group similar things together. You can see the similarity, and you can also see the dissimilarity between different groups. Okay? And this is something you can learn from. Later I will talk about what this represents. Essentially, by making use of the auto encoder, you can do something, you can have a better understanding of the input. Here the input is just image. You have lots of images collected from different places, a lot of images. And you want to reconstruct the images with this structure. And finally, you can see, different things, different layers, or different places will give you different representation of the images. This guy represents face, human face, and this represents the cat nose. So basically, if the input is the face, human face, this guy will be very active, will be excited. You can see, and if the input is the cat, image with cat, and this image, this guy will be excited, and so on. So now you can see by making use of this, you have a higher level understanding of the input. Later you will see the structure. This is called deep structure, deep learning. Okay. So this is that's just for unsupervised learning. You don't have a teacher. You have data. You want to analyze the data. You want to see the property of the data. That's it. Okay. Just try to have those pictures in mind. Then you can see, at least you will see what those problems are and how you can solve the problem. And this is a very different scenario called reinforcement learning. And in the last decade, reinforcement learning received a lot of applications. So in simple learning, basically this mesh, right? Like it's a file. The teacher will say, don't touch it. Don't put your hand there. It's hot. However, over here, you don't have a teacher. Still, you have some feedback. If I put my hand there, it's very hot. It hurts, right? You can really receive feedback from outside, from the environment. And this is called reinforcement learning. You can you can get some feedback from the environment after you take some action. So, reinforcement learning has been used to train animals, right? If you ask animals, say monkeys, to do something, basically, if they do something very good, then you give positive feedbacks. You can give food or pleasure. And if the monkey does something very bad, you can give some punishment, right? This is how we can train animals. Although this is very cruel, but basically this is what we do, humans do. And can you just ask a machine to do the same thing? Yes, you can. This is called computer reinforcement learning. Essentially, it's the same thing. If the computer, if the system does something very good, then the reward will be very good. If it's something very bad, the reward will be very bad. And essentially, the computer or the system want to maximize the reward. This is how you can solve the problem. Over here, remember the mice, right? The mice wanted to get out the mate. So here you have action. This is the best setup for reinforcement learning. You have environment, and it's hard to see that. So you have environment here over here, and the mice have to take some action. He observe the environment, and whenever he takes action, you can see he will receive some reward. Okay, and over here you have internal state in the mind. There are some essential problems, essential quantities here. You have a state, you have action, and you have reward. You just want to maximize the reward. This is how it works. Okay, so there are so many applications. Here, let me just show you some videos. First one. You cannot see it, right? Let me change the setting. Give me a second. This is done. This was done by my former colleagues in Germany. You can see how they teach machine to play ping pong. At the beginning, yeah, and later you can see how ping pong really learned how to play. I'll skip this part. Not very good at the beginning. Okay, basically you can see the machine can really learn how to do so. Now there is no teacher, right? The machine just want to maximize some reward, some score. This is another thing, this is funny. Basically the machine can learn how to flip pancakes. This is exactly reinforcement learning. You cannot ask the machine to do exactly what the thing you want the machine to do, but you can design a system to give reward. Beginning is very naive, very bad. But later you can see, by trial, basically the machine is learning, trying to explore different things and try to maximize the score. After some time, you can see. Yeah, so basically the machine could do a perfect job just by making use of the reinforcement learning. And finally, this is about 9 years ago, this was kind of really big news, The best helicopter pilot was a computer. No one could do those things. It's just a computer. And you can see how hard it is for humans to do so. See? So this is a very famous application of reinforcement learning. And later, I think NASA developed some similar systems to do something similar, to solve for the military. Okay? This was done at Stanford 9 years ago.